On today's episode, we're going to be converting our Voxelab Aquila into a direct drive printer. And we'll do it using the Creality Sprite Pro extruder kit. Now first, I'll talk about the difference between our stock machine and a direct drive unit. And then we'll look a little further into the Creality Sprite Pro. After that, it's on to the installation. And finally, we'll take a look at all the prints that I've accomplished with the Sprite extruder. And that includes ABS, TPU, PC, and nylon. Because yes, just like Eddie Munson, this extruder is all metal. And here we go. Folks, welcome back. I am Leo of Prince Leo 3D. Thank you for joining me. And this is going to be a rock rolling episode because this is my most requested feature by far, converting our Aquila to be the direct drive, or more accurately, direct extrusion. And today we'll be using the Creality Sprite Pro. It is one of the most simplistic ways to do it. It's basically plug and play. Of course, it's not that easy. It never is. But at the end of this video, I think you'll be fully ready to install this unit and modify to direct drive. Like the rest of my videos, I try and jam-pack as much information as I can. It's going to be a long video, so please, I put chapter markers below that breaks this video up. If you're looking for a particular section or particular information, please navigate down below, find the chapter you're looking for, and head right there. Now the first thing I'm going to talk about before we get into anything else is the difference between our stock Aquila and a direct drive unit. So right next to me I have an Ender 3 Pro. It's going to stand in as our Aquila because right now all of mine are direct drive. This is the same setup, so it will help to explain. On our stock Aquila, it's a bowden style printer, which means the cold end of the extruder, which does the pushing and pulling of filament, is situated right over here behind this rail. And then the hot end, which is right over here, has a nozzle. This is what heats up and extrudes filament. This is where the filament gets ejected from, right at the bottom here. And you'll see they're obviously very far apart, so the gap that the filament has to traverse needs to be maintained, and we do it with this tube right here, this blue tube, and it's called a bowden tube. Whereas on a direct extrusion printer, the cold end, the extruder that pushes and pulls filament, is situated directly on top of the hot end where the nozzle is right here. It's all one unit. There's no need for a bowden tube or anything to maintain the filament path because it's directly on top of one another. Now these systems both have their own strengths and weaknesses. For a bowden system, because this filament path is so large, your retraction distance is going to be greater. I would say a stock machine like this is usually between 6 to 6.5 millimeters of retraction. That's something you would set in your slicer. And then also, because of that, printing TPU, a flexible filament, is going to be a little harder on a stock machine. Whereas a direct extrusion machine like this is going to be able to print flexible filaments like TPU much easier right out of the box. And the retraction distance on a direct drive is way lower. For this unit, my retraction is 1 millimeter, where this was 6.5 millimeters. Due to everything being on the print head and on the gantry, that means there's added weight in a direct drive system because it's all right here on our x-axis. Whereas the bowden system has only the nozzle and the fan shroud, so it's much lighter. So when we're printing with a direct drive system, speed and artifacts are something we're going to have to look for. If we're trying to print very fast, the extra added weight could hinder that. If we're having artifacts ghosting in your prints, it could also be due to the weight. You might have to slow your speeds down. And then, due to how the Aquila is built, we usually have a single Z-rod, just as this does, right back here. Now with that added weight, as the print head moves over to that non-supported side, this gantry could sag and dip down because it's heavier. There are things we can do to mitigate that. We can always add a dual Z-axis. I just did on this printer, as well as my S2 that's over there. I put a video out on that recently. But either way, it's something to consider if you're going to modify your printer to be a direct drive. Now, in my own personal experience, I really haven't seen much of a difference between a bowden system and a direct drive system. I can get quality prints out of both machines. The one thing I will say about direct drive, it can sometimes be harder to clean clogs and issues with the nozzle, simply because everything is right on top of itself. If you get a clog somewhere in this nozzle or anywhere in the hot end, it can be a little tougher to clean out than it would on a bowden system, where all you have right behind the shroud is the hot end. Other than that, I haven't really seen much of a difference personally. Now, there are a lot of different ways to convert our Aquila to direct drive. I chose the Creality Sprite kit because it's basically plug and play. We're going to plug this ribbon cable into our main board. It comes right up here and it plugs right into the extruder. This also comes with its own gantry. So we took the old gantry and print head off and we just popped this one back on. It was a very simple setup. And not only that, the components that make up this Sprite Pro are really, really nice. This is an all-metal extruder capable of printing up to 300 degrees C. It has a titanium heat break to do so. It also comes with two nozzles, one's brass, one's copper coated in nickel, which is fine. But another cool feature is the daughter board that's attached to the back of this extruder. So once you remove this extruder, there's a daughter board back here. That means if we want to replace any of the fans, the BL Touch, the thermistor, the heating cartridge, we no longer have to take the wires and then run them down to our main board. That's what this ribbon cable is for. The daughter board behind there is where we're going to make all our connections. So for instance, this is the wire I need for the BL Touch. It is really short. I don't have to trail these BL Touch wires all the way down to the main board. Now, strength, weakness, like anything else. The issue with the daughter board is that the connections are unique. So, for instance, this BL Touch, this is not a normal BL Touch connector. Any kit you get that has a BL Touch in it is not going to be able to connect to this daughter board. The connection on this BL Touch is a Molex Pico Blade, 1.25 pitch. That is a normal connection for plugging into our auto bed level, our BL Touch, our CR Touch. The opposite end is the same size. That is unique. Normally this is a larger JST connector that plugs into our main board, but this is the same connection on both sides. So that makes plugging a BL Touch into this daughter board kind of difficult. And going forward, you're going to see that's kind of the same thing with the fan wires and the heating cartridge. All those connections are slightly unique. So now for the BL Touch, 3 ways to go about this. 1, you could bypass that daughter board altogether. You could plug your BL Touch right into the main board and not use the ribbon cable. That's normal. 2, you can go to digikey.com and buy the same cable I did, and this is the easiest way to do it. If you want to use this daughter board, which you kind of do because it makes it look really clean, not a lot of wires or extra wires going to your main board, this is the way to go about this. Cable's only like $5, probably another $4, $5 for shipping, depending on where you are, and you can get this cable. Or you can do what I had to do because I didn't realize this daughter board was unique, and you can take 2 separate BL Touch cables and splice them together. Now I'm going to put on screen the pinout for the back of the daughter board, but if you can see here, this is the side that normally plugs into a BL Touch, and this is also the same connector. I took 2 cables that I had from other BL Touches, I cut them in half, I spliced it together, and that worked for the time being. It didn't look pretty, but it worked. 3 options: plug it into the main board, splice your own cable, or go to digikey.com and buy a cable. Why am I pushing digikey.com? I'm not. It's just the only place I found that has this cable. I looked on Amazon. There are a few options. Nothing matches this. I'm going to leave a link in the description to this product, so if you want to buy it in advance or even after you've gotten the Sprite, you can do so. Now, speaking of the description, there's a lot of information down there, so please read it. I'm always updating these videos with experience I've had since I put them out, or if someone in the comments corrects me, which I love when you do, I really appreciate it, I add it to the description. So please peruse the description, see if there's any updated information or anything else you might need to know about this project. So I talked about the Creality Sprite being all metal. It can print those high temperature filaments. It also is a dual geared extruder, which means it's going to be able to push and pull the filament with more precision because it has those 2 gears doing it. Now, one thing you're going to want to check is how tight those gears are. If you see filament leaving your machine very dented or very marred up, it could be because the gears are a little too tight. Pretty cool way that they've included to adjust that, and that's right here. This is how you adjust the tension on those 2 dual gears in the cold end extruder. You can get an Allen key right in there, and then you can tighten it or loosen it as necessary. Another thing I noticed with the Sprite extruder, and that is the screw that holds in the thermistor wires is so large that it's actually touching the wires going into the heating cartridge that's next to it. Now, I don't really know what damage, if any, this can do, but I really don't like it. Now, I actually asked this question in my Discord, and we had some great responses, and one was very smart. kind of forest for the trees. Loosen the heating cartridge, rotate it 90 degrees, so this way those wires are oriented out of the way. Great option. That's what you can do if you want. At that point, the screw should no longer be touching those wires. But definitely, when you mount this, look for that. See where the screw is and see if it's touching those heating cartridge wires. And if it is, rotate it out of the way. And one last really nice feature that I thought the Sprite included was ferruled wires. All the cable ends for this have been ferruled. What that means is, normally in a 3D printer, the end of the cables that got plugged into terminals on the main board are just exposed wire, and then sometimes they get tinned, and that can be a fire hazard. What Creality has done with this is ferruled those cable ends, and all that means is it's like a metal tube that goes on the end, it gets crimped, and now there's no longer any exposed portion of the wire. Those terminals get plugged into our main board, and there shouldn't be any more danger of exposed wiring. Now the build volume. On the Aquila printer, the stock build volume is 220 by 220. However, we can increase that build volume in the firmware because in actuality, this is a 235 by 235 build surface. So we could use all of that by making some firmware adjustments. However, with this Creality Sprite Pro, I was only able to get up to 225 on the x-axis because the way this mounting bracket sits, if it goes too far over, it's going to hit into this passive block, and you won't be able to get past 225 on the x-axis. So with the Sprite Pro extruder, my build volume is now 225 in the x and 235 in the y. Now if you're looking for firmware for the Aquila, after you include this new Sprite Pro extruder, you can go to my website, printleo3d.com. It's going to have everything you need because now this is an all-metal printer. It can print 300 degrees Celsius. The stock firmware, or even Alex's firmware, is made for a stock machine that can only reach 260 degrees Celsius. So I've modified Alex's firmware to do a few things. One is reach 300C. Two, I've brought the build volume to 225, 235. So you're going to get the max value out of your build volume. I've also increased the E-steps to what Creality called for, 424.5. And then finally, I found out what the X and Y offset was for this probe, and I've installed it into the firmware. So you really shouldn't have to do any of that legwork. Again, printleo3d.com, navigate to the firmware section, and you should be able to find it. Now we've talked about it, we've seen the differences. Let's go ahead and see how we install it. I promise, not really all that difficult, even though it does look like a long video. I just try to go through everything step by step. So let's go ahead and get to the installation of the Sprite Pro extruder on our Voxelab Aquila. So here's the box that my Sprite showed up in, as well as all the components that were in that box. It came with an instruction manual that gave the initial E-steps, as well as a guide on how to hook it up. It also came with all the screws we needed and an additional nozzle. The nozzle that comes equipped on the Sprite is a brass nozzle, while this one we're looking at here is a copper nozzle coated in nickel. Copper, known to be a better conductor of heat. Nickel is known to not let filament stick to it. So this is a nice option that was included. I mentioned it earlier, but here are all the cable connections, and you'll notice again, all the loose wires have been ferruled. Here's what the entire cable bundle looks like. And here's a plug that's going to connect on top of the Sprite. And here's the mounting bracket. When we remove our hot end, we're also going to remove the carriage plate that's on the x-axis. This mounting bracket is then going to go in its place, and then our Sprite hooks directly up to this. It's very simple. And then next we have the Sprite itself. And you'll notice it's a very compact design. A lot of direct extruders don't allow you to get the full access of your vertical volume because of their height, but this is a compact design. It's nearly the same height as my original Bowden hot end. And now here's that daughter board I was talking about. This is where you're going to make all your connections if you want to replace a fan or a thermistor wire, and this is where you'll plug in your BL Touch as well. Here is the air duct connected to our parts cooling fan, which of course is what blows cool air on the extruded filament and cools down our parts. My air duct was cracked right out of the box. Not sure if it's Creality's fault or just during delivery these things tend to happen. I'm not sure, but it required some immediate action before we installed it. And one more thing, literally as I'm doing the final edits of this video, someone from my Discord, true to their name, my boy Blue, came through and let me know they had just bought the Sprite extruder and their kit came with that dedicated BL Touch cable. So for them, going to digikey.com and buying it or having to splice a wire was not an issue. Will you get this in your kit? I have no idea. I didn't get it in mine. But it's good to know at least some people are getting them and they are available for some. Like I had mentioned when I received my Sprite right out of the box, the air duct was cracked. Air would have leaked out. It would have provided really poor parts cooling. So what I did was I went into Fusion 360. I mocked up a very quick design, printed that out in ABS, and I was able to repair it before I even had this extruder mounted on my printer. If you have to work on this shroud or even the nozzle while it's on, here's an easy way to access it all. There are 3 screws that hold this fan in place. We only need to remove one. That's the top one here. The other 2 can be unscrewed very lightly, and we can move the fan out of the way. Then we can tighten one of those screws, and it stays in place. This way we can either access the nozzle or the fan duct without getting in the way of anything else. After that, I unscrewed the fan duct. Only needed 1 screw to take it out because the other one was clearly cracked off. And then I replaced it with that ABS air duct that I had made. This was printed in ABS Overture Blue filament. After securing the air duct, I lower the fan back in position, and I put the screw that I took out right back in its place, and I tighten the under screws down. After that, my Sprite was ready to go, so I wanted to start with the wiring. First thing we have to do is get access to the main board that's under our printer. So there are 4 total screws that we need to remove to access it. The first one is right here on top. After that, I flip the printer over on its side so I can get access to the bottom of it, and I take out the remaining 3 screws. Be careful when you remove that last screw. The main board cooling fan is attached to this piece of metal we're removing, and if you yank it out, you are going to yank the main board cooling fan out of the main board, so be really gentle with it. Now what I did during this installation is I unplugged that fan completely and I got it out of the way. I knew I was going to be doing a lot of jostling in there. I didn't want to pull the fan out accidentally. You don't have to do this, but if you want more ease of access, a little more room to work, not a bad idea to remove it. So before we watch the installation, this is a picture of our main board. I want to show you where all these wires are going to be plugged in because it's really not that complicated. Starting at the bottom left, here is the hot end fan. That's the insert for that. To the right of that, we have the heating cartridge, goes right there. Next to that, this bottom port right here, that's the parts cooling fan. They will be plugged in there. All the way to the right, hot end thermistor gets plugged in there. If you'd be using a CR Touch or a BL Touch, it gets plugged in right there. The last plug we have is for the extruder motor. It gets plugged in right there. Very, very simple. Only 6 total plugs. You are going to have 2 left over. There's 8 total plugs. Those are redundant cable heads. Don't worry about them. Now that we've seen this basic layout of it, let's go ahead and see what it looks like when we do it on the actual printer. First thing I'm going to do is remove this wire so I have access. Then I'm going to remove the parts cooling fan. That was the plug I just unplugged. After that, I go to my BL Touch. My BL Touch is not a single plug, it's a 3-pin cable and a 2-pin cable. So I take those out. After that, I go to the extruder motor cable. That's the one all the way at top. Now, sometimes these cables are held in with glue. If they are for you, you might have to get a pair of tweezers or something in there. Gently remove that glue that's on it. Now, it was at this point I decided for the video only to remove the main board so there was a kind of a better angle to watch me doing this. You don't have to do this. If you feel like if you got some really chunky hands or you don't have enough room, removing the main board really isn't that hard. It's 4 screws. You're going to see me do it now. Make sure you remove that SD card as well, because if you don't, it's going to stick out and you're not going to be able to remove that main board. Now that I have the main board out, I kind of free up that extruder cable just a little bit because eventually I want to remove all these cables from that wire harness, so I want that extruder cable kind of dangling out by itself. After that, I'm going to remove the wire to the hot end thermistor. That's the one in the bottom right there. Next, I start with the heating cartridge. And all you're going to need is a small flathead screwdriver that should have came with the printer. You'll loosen these terminals up a little bit and the wire should slide right out. After the heating cartridge, I go for the final portion, and that is the hot end fan. Again, I am loosening these terminals and the wires will eventually just slip right out. Now before I actually install the new Creality direct drive plugs, I want to just clean up all these wires. So I'm sliding the big braided portion down close to the main board. It opens it up and I'm passing all the wires I've unplugged back out through the other end. I'm not going to need them anymore. The final wire that I pull out is the wire for the extruder motor. And now here's a shot of the main board, what it looked like before I installed my Creality Sprite extruder. Yours is going to look just like this, except you might still have the ribbon cable in for your screen. I removed it just for this video so you could see a little better. So now it's on to installing, and this is really simple. We pulled out, now we're just going to push in. We start all the way to the left with that hot end fan. It's going to be the two wires marked fan plus and fan minus. The fan plus is going to be on the left side of the terminal. That's that red wire. And the fan minus, which would be fan negative, that's going to go to the right of that. And now the fan negative goes into the right side of the terminal. And I tighten it down. When you insert these, you want to make sure they are fully inserted. I do not do a good job during this portion of the video of doing that. Later on, I go through, I push these ferrules all the way in. We don't want any metal to be exposed. Now, these cables are also all ferruled, which is awesome. Sometimes loose wires get tinned and they can be dangerous and a fire hazard. Next, we move over to the heating cartridge wires. Just like all the other wires, heat plus is going to go on the left side of that terminal and heat minus is going to go on the right side of that terminal. Now, I'm going to cover this later in the video, but it's possible you might need to swap these wires, even if you did it correctly like I did. Once we get all this installed, we're going to check to see what happens when we heat up our hot end. If we try to heat it up and the power turns off, that means these wires need to be switched. Doesn't mean you did anything wrong. It means you followed the diagram as is, but for whatever reason, how the Sprite's hooked up, those two wires now need to be switched. After that, the next wire I plugged in was the thermistor. That's the one all the way to the right, and it's marked TB. And then after that, I plug in the parts cooling fan, and that's labeled K fan. After that, I plug in the CR touch cable. And then after the BL touch cable, the last cable is marked E for extruder. It gets plugged into the top, and we are basically finished with plugging in the wiring. And then right here, these are the two extra cables you're going to have. Again, they're superfluous. Don't worry about them. They have no home. You didn't forget to plug anything in. They're just extra cable connectors. Now after that, I resecure my main board. Again, 4 screws that come out go right back in. It's really not that hard. So if you also removed your main board to make this a little easier for you, this would be the way you get it back in. I start with my top screw, line everything up, and then the remaining screws go in. And as you can see, I also removed the ribbon cable from my screen, again, to make it easy for you to see during the video, and it's at this point that I replace that ribbon cable. Now, the only weird thing about this installation is this wiring harness is extra thick, so make sure you run it through the cutout channel in the extrusion, and it's not getting pulled on either side of that sharp portion. And then once everything's secure, we button back up our mainboard case. If you unplug the mainboard fan, plug it back in, and then the 3 screws we took out on the bottom go right back. Make sure again you're not snagging any cables. The ribbon cable to the screen isn't caught, and the cables going out and up to our extruder and our stepper motors aren't caught either. And then once you've righted the machine, don't forget to get that last screw that's holding that mainboard casing, which is right below the bed. Now after the wiring's hooked up, it's time to remove our old hot end and our old cold end extruder. I start here. I have the BMG clone on. You might have just a regular stock extruder. Process is the same. There's either 3 or 4 screws. The BMG clone has 3 screws. The stock extruder has 4. Now what you do with these is completely up to you. This kit comes with everything we need. So this is going to be an additional stepper motor and an additional extruder that you can use on a different printer, or you can just have for spare parts now. Remember, when the last screw comes out, that stepper motor is going to fall, so make sure to keep your hand under it. Next, I remove the belt. Very simple. It's tucked into 2 little slots. I just untucked it from either side. The belt comes free. And I'm not going to remove it entirely because I'm just going to re-secure the belt when we put the new extruder on. Now we're going to remove the hot end, and we're going to do that by removing the lower wheel. All 3 of these wheels are fixed in place with a screw and a nut holding it on. And for the bottom wheel, we're just going to loosen the nut, remove the screw, the wheel will come out, and the hot end can be removed. If that bottom nut is spinning the screw while you're trying to loosen it, you're going to have to remove the 2 top wheels. That way you can get a screwdriver in front of the screw for the 2 top wheels and remove the nut. Now what we did to remove our old hot end is what we're going to do to replace our new hot end. We're going to remove that bottom wheel, and this wheel is also the one that has the eccentric nut, also known as the eccentric spacer. So for this, I'm doing the opposite of what I did last time. I secured the nut with my wrench, and now I'm unscrewing it from the other side with my Allen key or my Allen driver. And after it's loose, the nut comes off, the wheel comes off, and the eccentric spacer can come out as well. Now this next part can be a little tricky, hard to explain, but I guarantee as you try to mount it yourself, you'll get a feel for what we're trying to do. And remember, when you're mounting this, the wheels need to be facing the back of your printer, as this is a back view we're looking at. The first thing we're going to do is lay the disassembled mounting bracket onto the extrusion. After that, we're going to run the screw through it and then the eccentric nut. And now what we're going to want to do is get the wheel onto the screw and in place under the extrusion. Now this is the tricky part. As you're attempting to get the wheel onto the screw, it's going to be butting up against the extrusion. What you're going to want to do is, you can kind of see my hand doing it, rotate that eccentric nut. It'll bring the wheel closer and further from the extrusion as you keep moving it, and you can eventually squeeze this wheel under the rail and in place. Now keep in mind, the bracket needs to be straight up and down. If it's angled and you're trying to get the wheel under it, it's not going to fit. You need to make sure the bracket is not angled and it's straight up and down in order for the wheel to sit snugly. Once that wheel is in place, I make sure I want to tighten the nut down in the back fully, and then I have to adjust the eccentric nut. I don't want this plate to move at all, and as you can see right there, there's a lot of movement in this plate. So I start turning the eccentric nut. That starts bringing the wheel closer to the extrusion, and I get it to a point where it's no longer making any big movements with my hand. That's exactly where I want it. Now it's time to reinstall the belt. Now we're looking at the back side of this again, and the belt slides into the 2 belt grooves that are already there. One side has a single groove, the other side has 2 grooves. So if your belt only reaches the first groove, that's fine, put it in there. If you have enough belt though to go to the inner groove, place it in there. You may even need to loosen your belt tensioner for this, like I did. I loosened my belt tensioner, I was able to stretch the belt out to that inner slot, and then I tighten it back up. We are almost at the finish line, but before we hook the Sprite up to the mounting bracket, this is the time to make any connections to that daughter board behind it, because once it is hooked up to the mounting bracket, you don't really have a lot of room back there. So one connection everyone's going to have to make is the heating cartridge wire. It comes unplugged from the factory. All you need to do now is plug that in. And then if you are hooking up a BL Touch or a CR Touch and you are hooking it up to the daughter board, now is the time to plug that in. After you made all your connections to the daughter board, we can now hook the Sprite up to the bracket. And it's simple. 4 screws, they all go on the same side. Just make sure you put them in all one by one, tightening them up as you go. And then after they're all in, secure it firmly and make sure the Sprite's not moving anywhere. And the final step is to plug in the ribbon cable. One end we already plugged into the main board. Now the other end comes up and around. It's a very long cable and gets plugged into the top of the extruder. Now remember to open up the arms of the cable adapter so you can fit the cable in there, and then once it's in snug, the arms will close up around it, locking it in place. everything mounted and assembled, we can now power on our printer and check for a few things. First, are the fans working? Second, we want to heat up our nozzle and make sure our printer doesn't restart. It's a common issue with these Sprites that when you're trying to heat the nozzle, it will restart the power on your printer. If that's the case, which it was for me, you have to go back into the main board and swap the heating cartridge wires in orientation. That means positive goes to negative, negative goes to positive. Nothing you did wrong, it's just on some of these models, that's how it works. After that, I do all the base calibrations I normally would. I start with the E-steps, and on a direct extruder machine, I need to remove the nozzle so I can get the filament directly out of the heating block. I need to disable the cold extrusion safety feature. I made a line and G code, I saved it to a text format, and I simply printed that. The printer reads that G code, it disables the safety feature, and I can perform my E-step. Now the manufacturer recommended E-steps was 424.9, I got 422.5. Not a big difference, but a difference nonetheless. After I saved that, it was time to reassemble everything. And when I put the nozzle back on, I made sure to heat tighten the nozzle. And of course, whenever we're working on this nozzle, the power to our printer is off. We don't want to accidentally touch a thermistor wire and blow our main board. The next calibrations to be done were finding the X and Y offsets for my BL Touch. Then I found and adjusted my Z offset. And after that, I re-leveled my bed. And then the last thing I did was PID auto-tune my machine. I want to calibrate the temperature to my environment, so that's what PID tuning does. I have Alex's firmware installed on my Aquila, so I was able to do that directly from the menu. And now finally, we load filament, and this is where the fun begins, because we can start printing. My first print is in PLA, and I'm printing a flow test. Now at this point, the only slicer adjustment I have had to make for this direct extruder printer is by lowering the retraction distance, and I made my retraction distance 1 millimeter in length. Now after this flow test, I'm going to adjust the flow in my slicer, and I can start printing larger models. The first print I wanted to see after a flow test was an overhang print. Now this isn't your standard overhang test. This is actually a lightsaber hilt holder that I mostly print for my father, who has an abundance of a collection. I've printed this holder so many times, I can get a really good estimate on how well the overhangs are printing. And this printed it perfect. It was spot on. Next, we tried a longer print, and this was a black noir bust from the TV show The Boys, designed by Fotis Mint. And this model is amazing. This was printed in Polymaker matte black PLA, and it came out completely stunning. The overhangs were amazing, and this model really was remarkable once I peeled it off the bed. For our next filament, I wanted to turn up the heat, so I chose PETG. This is inland translucent green PETG, and I am printing out a dialed down scorekeeper. And once again, this Sprite was completely up to the task. The dial fit together perfectly and had a very satisfying snap for each of the numbers. The next hurdle for the Sprite was going to be flexible filament. And right here, I'm going to try and print Overture TPU. Now for every new filament, I also performed a flow test. And on my TPU flow test, it wasn't quite right. So I started with one of these calibration dragons, or Cali dragons. After printing this, I realized I was printing too hot. I lowered my temperature, and my TPU prints came out amazing. And I started on this articulated octopus, which is generally a hard print. The Sprite tackled it without any issues, and TPU was in the bag. And all the profiles I'm printing with, you can find on my website, princeleo3d.com. Then I moved on to another high temperature common material, ABS. And right here, you're seeing a different flow test that I've used. Sometimes I will use a hollowed out cube as my flow test, but more recently I've been trying a more aesthetic approach and a different way to do it. This is Overture Blue ABS, and I'm printing a print in place ratchet driver. And this is a really cool print. It shows the precision that this printer and Hodden are capable of by being able to articulate this print in place model. And when it finally was finished, it was completely capable of working. Really cool design. ABS was over, and now it was time for PC, polycarbonate, another high temperature filament. I found a 6-piece model online to check the printing tolerances. After a flow test with this new material, it was off to the races. and the printer did a phenomenal job. Now there is a tremendous amount of stringing, but I have to imagine that was my fault for not quite calibrating the temperature settings. And of course, PC is known to be very hygroscopic, and I could have done a better job at drying this filament out. This produced yet another functional model that went together easily and functioned as was intended. And finally, this is the last of our high temperature filaments, and this is nylon, also known as polyamide or PA. And what I'm printing is only a 2-piece model, really just looking to prove if in fact this hot end combo can print nylon. This is Inland brand nylon, and just like all the other filaments before, the Creality Sprite handled it perfectly. This model is a carabiner. It is in 2 pieces. It snaps together. It still maintains the flexibility of nylon, but also the strength. Yet another check mark in the list of filaments this hot end can print. Folks, that's it. We've installed our Sprite Pro extruder. It really wasn't all that hard. We printed 5, 1, 2, 3, 4, 5. We've printed 6 different materials, some high temperature materials. And I gotta say, all my prints turned out really well. And due to the complete time sink that these videos are for me, I've actually been printing with this for about 3 weeks. I've gotten over 500 hours of printing with this Sprite since I recorded the portions of this video that you've seen. And I have to say, it's been tremendous for me. I've really liked printing with it. No issues to report thus far. So if you're looking to install this on your Aquila, go to my website, look for the firmware. It's going to give you access to those high temperatures that this can print with. It's going to give you the proper bed size, the proper offsets. It's going to already orient your E-steps, although I recommend, just like I did in the video, calibrating the E-steps for yourself. And then you'll find some other articles there, some other things to peruse and check out for 3D printing. Now with the Sprite, we talked about the daughter board and the fact that we can make all our connections behind it instead of in the main board. It's a really cool concept. And there is a user on Reddit, Classic Rocker 883, who's familiar to the Voxelab Aquila subreddit, who's looking to put out a daughter board for the Voxelab Aquila. Pretty cool stuff. I'm going to try and put this through the paces, see what it's like. This might be a really cool option for our other Aquilas, our bowden style Aquilas. This is a daughter board where we'll make all our connections right up here. The wires go into the main board, and we don't have to worry about trailing wires anymore. We can just make all our connections up here. So it's something to look out for. I'm going to put some videos out, maybe some on TikTok, maybe some on YouTube, and we can see exactly how this turns out. Well, folks, as always, thank you so much for staying this far. If you have, I really appreciate it. If you haven't yet, please subscribe. It helps the channel. Hit the like button. Also helps the channel. I have a website. I've talked about it a million times. I'm not going to mention it anymore besides that. Really, thank you, thank you, thank you. I'm nearing 2,000 subscribers right now. Blows my mind every time. Join the Discord. We talk every day. Join the conversation. We would love to have you. Check out any of my social medias, Instagram, TikTok, just to have a little bit of information between these longer videos, because I'm always putting out small blips and blurbs of anything I can 3D printing related. Thank you for staying this far, and until next time, as always, boys, girls, everybody else, keep on printing.